Hi everyone, welcome to Local Project Lecture. I'm Yuan. I work on robotics in Dai Level and have worked on humanoid robots in the past years. Our lecture will be programming humanoid robot in Python. Today is the first lecture. I will give you an overview of the lecture, what you can learn from this lecture, and what is fun there. Hope you will enjoy. So let's look at our robot. This is a humanoid robot now. It has a computation unit in the head, which is the Intel Atom board, runs embedded Unix as an operation system. The robot also equipped with a rich set of sensors, including 2 cameras, which is here and here. And it also got IMU, so it can sense the body orientations. Of course, for each joint, as a humanoid robot, it gets the joint angle sensor. Furthermore, it got a force resistance sensor on the foot, so it can sense the force applied from the bottom of the feet. So in this lecture, we are going to learn how to make perceptions from these sensors. For example, how to use the camera to recognize the environment, how to use the joint sensors, use the IMU to recognize the current state of the robot, and also how to use the foot sensor to balance the robot. And what actually makes this robot really unique to any other kind of robot is its humanoid robot. So it has 25 degrees of freedom, so 25 motor joints, which can be controlled individually. And of course, it also gets other sensors and actuators, which is less important, but they are also useful in many cases. In this lecture, we are going to learn how to program this robot in Python. In the end of this lecture, you should be able to program the robot to accomplish tasks like finding the ball with the camera, make motions, to getting closer to the ball, and so on. Ultimately, you should be able to have a robot work autonomously by given tasks as your final project. As examples, final project can be playing the soccer or serving you a drink. In Dai level, we have a team of 8 nodes, and we have attended several events in the past years. The biggest one is the RoboCup. We have a team of 5 robots playing soccer against other teams from other universities. We have also showed our robots in the university's ceremony to the Queen. We have demonstrated our robots driving a small car autonomously in CBIT, and we show our robots playing tall season, and that's penalty kick to the hole in the Night of Science many years. In this lecture, we are going to use a simulator so that you can practice and programming at home in any time. The simulator we are going to use called ThinkSpark. It is an open source simulator available in all operation systems you can download the pre-compiled binaries for Linux and Windows from our project website. Especially this is also official RoboCup simulation league simulator. So it means if your program is really good, in the end of the semester you can participate in the simulation league to compete with other teams. Get interested? Is it hard? We will use easy but powerful Python in the programming. So maybe many of you already know Python. There are many great libraries available in Python. We are going to use them in our lecture, including NumPy, Matplotlib, and so on. During the lecture, we will also demonstrate how to learn and use Python in robotics. I hope it will be your favorite programming language in the end of the semester. Here is the basic plan for our lecture. You are expected to have basic knowledge of linear algebra and some basic programming knowledge. The target of the lecture will be programming humanoid robot. The teaching content will include joint control, keyframes, pose recognition, forward kinematics, and inverse kinematics, and so on. It will also cover motion, computer vision, and so on. The lecture will be structured in 6 teaching cores and 6 correspondence exercises. So in each lecture will be around 1 hour, and it will be presented in 2 weeks. So it means every 2 weeks we have 1 lecture, and you are going to have 1 exercise. The exercises will be programming in Python. We will provide example code or structured code. You will only need to complete the missing part to accomplish some tasks. And finally, as we are project lecture, you are supposed to finish a project within a team. So I expect you make groups with your classmates. So, and you work together to make a robot work on autonomous tasks. We will talk about project topics later. We are going to have content from next week. So for this week, you have simple tasks. That is, find your team, which I think contains from 3 to 4 person. And you can also already start to set up your software environment. And everything for software we are providing in the GitHub. You can find more information in our dynamite.de website or other useful links provided here. Some final notes for this semester because of the virus. So most likely we will have online lecture only. When everything goes better, we may have a face-to-face meeting and work on the real robots. If that was not the case, we also will work on the projects in simulation. If you have any questions, please ask in easy form. I will try to answer your questions every day.